In episode number 1, we took a look at the introduction to stoichiometry, and I took you through the mole to mole ratios, which essentially is all of the new learning. I did one example problem with you where we started off with 20 moles of carbon dioxide, and we calculated how many moles of lithium hydroxide we had, and we learned how to set up our conversion factor, and we got our final answer. We're going to move along, and we're going to talk about how to introduce grams, and we'll go through 3 more example problems, and we'll eventually end up with gram to gram calculations, which for the purpose of a laboratory is more important than anything that involves moles. The moles are just a middleman. We have to use digital scales in order to measure anything in the lab, and so knowing how to do the gram to gram conversions a lot more practical for our purposes. So let's continue on. Example problem number 2. I'm going to use the photosynthesis equation here, give it to you balanced. We got our little mnemonic up here at the top. Question is, how many grams of glucose is made if 3 moles of water react? Well, what our given is 3 moles of water. So we're going to start with moles on this side. Remember, this little mnemonic works where the grams and moles on the left-hand side are of one substance, and the moles and grams on the right-hand side are of a different substance that we're comparing it to. So we're starting with 3 moles of water. So here's our start point, and I'm going to figure out how many grams of glucose are made. And I always like to write my givens and what I'm going for above my chemical equation to kind of keep me on track and learn what I need to do with it. You use the mnemonic and you see we have to cross 2 arrows. That tells you that there's 2 steps to the conversion factor. Writing down what we've been given, 3 moles of water. Moles of water has to go to the bottom. Moles of glucose, because we are converting from moles of one substance to moles of another substance in our first conversion factor. So we have moles over moles. When you have 2 different substances being compared, you have to go up and you have to look at the chemical equation. 6 goes with water, 1 goes with glucose. The moles of water are going to cancel, leaving me with moles of glucose. So moles of glucose has to go down here to the bottom. We're now at this M, and I'm going to grams of that same substance. So grams of glucose goes on top, and when you have the same substance, 1 goes with moles, and I need to find the molar mass of my glucose. And my molar mass are 6 carbons, 12 hydrogens, 6 oxygens. Molar mass of carbon is 12, hydrogen is 1, oxygen is 16. Rounding those numbers off to 2 decimal points off of a periodic table gave me 180.18. On your calculator, you would take 3, divide by 6, times 180. Well, 3 divided by 6 is a half. 1/2 times 180 is about 90 grams of glucose being made. Alright, so this introduces how do we get the grams into it. Let's take a look at another one. This one is mass to moles. This time I'm starting with 132 grams of carbon dioxide. So I'm starting with the G on the far left, and I'm going to moles of water being reacted. So my start point is grams, my end point is moles. I have to cross 2 arrows, so that tells you there's going to be 2 parts to this. So I put my information up here at the top. I'm starting 132 grams of carbon dioxide. So grams of carbon dioxide goes on the bottom. And I'm converting to moles of the same substance. So moles of carbon dioxide goes on top. Same substance, 1 goes with moles. Look up the molar mass of carbon and oxygen. Find those, add them up, 144 about. Grams of carbon dioxide cancel. We have 1 mole of carbon dioxide left. So moles of carbon dioxide goes down here to the bottom. And in this one, I'm going from moles of carbon dioxide to moles of water. So that's 2 different substances. 2 different substances, I need to get the mole ratios from the equation. So there's 6's in both of those. A 6 in front of water, a 6 in front of carbon dioxide. As you can tell mathematically, this step is useless to us because 6 over 6 is 1. So all we have to do on the calculator is 132 divided by 44, and our final answer is 3 moles of water being made. Now, if we know there's 3 moles of water being made, we could take it one more step, couldn't we? I can convert moles of water into grams of water. That's a piece of cake. Again, the only new information you got in this whole chapter so far is this molar conversion part. So let's take a look at going the whole distance. We start with grams, and I'm going to calculate the amount of grams of another substance. This time we got a 10 in hydrofluoric acid reaction. And I'm starting with 30 grams of hydrogen fluoride. How many grams of SNF2 can I make? So this is a gram to gram calculation. In order to go from grams to grams, I start here. I cross 1, 2, 3 arrows. 30 grams of HF. How many grams of SnF2? So I start with 30 grams of HF. In my first conversion, I'm going from grams of HF to moles of that same substance. So down here in the conversion factor, I have grams of HF on the bottom to cancel, moles of HF on top. I got the same substance top and bottom, so 1 goes with moles, and the grams gets the molar mass. Hydrogen plus fluorine, look them off the table, that's about 20. Grams of hydrofluoric acid cancel, or HF, whatever you want to call it. I'm left with moles of HF. My next conversion is moles of HF into moles of tin fluoride. So moles of HF go to the bottom, moles of tin fluoride go to the top. I have 2 different substances. So this means I use the mole ratios. 2 for HF, 1 for tin fluoride. So that would be 1 over 2. That cancels out the units of moles of HF. Gone, gone. I'm left with moles of tin fluoride, so moles of tin fluoride go to the bottom. And now I'm going from moles of tin fluoride to grams of tin fluoride, the exact same substance. Since it's the same substance top and bottom, 1 goes with moles, and I need to get my grams, my molar mass of tin and 2 fluorines. That came out to be 156.71. 30 divided by 20 divided by 2 times 156.71. And our answer is 117.53 grams of tin fluoride. That should take you back through all of our calculations. I have done, excuse me 1 minute, I've done everything for you from a mole to mole calculation and a moles to mass calculation and a mass to moles calculation and finally a mass to mass calculation. At this point, you're pretty good to go on your homework practice if you're a Milton Union High School student. Our next topic in our notes will be limiting reactants. But for the most part, we're going to be working on getting proficient at doing these problems and doing a substantial amount of lab work to actually get in practice, because the theory of this is all well and good, but when you actually start getting beakers and test tubes and stuff out and how do you actually capture something, it gets to be a little bit more difficult. Thank you, and I'll see you in the next episode.